Okay, so the problem we are discussing today is reversal linked list. So what do we mean by reversing a linked list? I have here a lead code question 206, which is asking us to reverse a linked list. So let's take an example. Let's say there is this linked list. Sorry, uh, we have 5, 4, 7, 9, 6, 8, 6. So reversing a linked list as it is very understood that I have to reverse this linked list. So if this is given to me, I have to change the order of this linked list, right? So now the order will be like 6, 9, 7, 4, 5, like this. I think this is clear to everyone, right? This will be our answer. So how can we achieve this? So if you know that there is something which is known as uh, swapping two numbers. Let's say I have A, I have B. We have some sort of, intuition, or I can say this is a little bit similar to this. This is not the solution, but can have an idea. So A is 4, B is 3. So if you want to swap this, how can you do it? We can have a temporary variable, right? And we can say temporary variable is equal to B, and it will store 3, right? So now I can say my B will be equal to A. Now my B will become 4. Now I can stay my I can store my temporary value, which will in turn be equal to 3, right? So now B becomes A and A becomes. So I have used a temporary variable 10. Similarly, we have a logic here to reverse the connection between this, right? What I will do, how I can achieve this is I will, try run one group, and then we can decide how the logic is happening. Let's have this linked list 5, 4, 7, 9, 6, right? This is connected like this is connected like this is connected like this is connected like this. Here it is null, and here we have our right. So reverse means like this is connected to previous, this is connected to every node is getting previous, right? So what I can do, if somehow my 5 is connected to 4 and 7 is connected to 4 is connected to 5, 7 is connected to 4, 9 is connected to 7, 6 is connected to 9, right? And this is pointing to null, and I return this as my new head, right? Then I can say the head return gives me the linked list which was provided to us in a reverse order, right? So to achieve this, what I can say, I have to point it to a previous node, which is not there, right? So 5, 4, 7, 9, 6, right? This goes to here, goes to here, this goes to here, this goes to here. What I'm saying that there is another element. In the first step, what I'm doing, that I'm pointing this step 1, right? I'm pointing this to its previous element. Let's say I have a previous element here, null, right? It's pointing to null. So what, and this will be pointing to 5, 4. So, and what I'm doing, I'm erasing this link. This link is being erased, and now this is pointing to its previous element. So now, in next step, what I will do, I'll do the same thing, right? 5 points to its previous element, 4 will point to its previous element, and then next link, which is 7, 9, 6, and this link with this one will be removed, right? Now this is getting removed, right? In the step 2, let's say this is our step 2. Let's change the color. Let's take this color. This is step 3. So 5 already points to its previous, 4 already points to its previous. What I will do, 7, now 7 will point to its previous, right? And then what I will do, I'll remove this linkage, right? I'll remove this linkage. So this linkage will be removed. Okay. So there is a pattern to it, right? So what I'm doing here is there is this previous, right? In this case, this was the previous, and there was this current, right? The current is pointing to the previous, and it is removing its currents next. So currents next is being, this one is being moved to its previous, right? And then previous is now the current, and current is now the and next is now the current, right? So let's let's let me show you here what is happening. Let me anoint this. Let's take a yellow color. So this is previous, this is your current, right? So in step 4 what will happen? In step 4 5 is already pointing to this, 4 is pointing to this, 7. So what I have to do, I have to you know have a pointer in such a way that I don't lost. If I point my currents next to previous, right, let's say I directly points this through here and remove this connection, then I don't have a linkage to my 6. I don't know where my 6 is, right? So I need a pointer which points to 6, correct? So what I will do, i will I will have my next. So first of all, what I will do, I will store currents next in next. So I will be storing this information, right? Next. And then I have this next pointer. Now what I will say is that points currents next to previous. So 9 will be pointed to 7 now, right? And I have 6 goes to this. Now my previous will be current, so I will update my current equal to previous, right? So sorry, previous will be current, right? So previous will equal to current. This will be my new previous, and current will be my next, right? Which will be here. So my this will become like current will be equal to next. So it will be like this. So in the next step, what will happen? It will be like this. 5, step 5. This 4, 7, right? 9. So we have to keep track of our next segment, right? So this is next, or I can say this is a temporary variable, right? As I said in the reverse example. So this is the next, and currents will next will be previous. The 6 will go to 9, and then this will be pointing to null, and this will become now previous. Current will become previous, and the current will become previous, and next will become current, right? So I have to iterate this till my current becomes null, and previous header stores the new reverse linked list, like 6 points to 9, 9 points to 7, 7 points to 4, 4 points to 5, and 5 points to 9. Right, so this is our new head, which is previous. This is our reverse head, we can say. So this is a dry run. This is super clear now. If you have any doubt, I will say to rewatch this video. It will become crystal clear, and or drop your doubts in the comment. Now we will write the pseudocode for this problem, how we are encountering this. So what we are provided with head, right? In our problem statement, we will be provided with the head. So let's say I have to have a previous, sorry, we'll say node star previous. If you remember, it was initialized with null, right? This was null. So your previous is null. This is clear. And your current was head. We started from head, right? If you see, we started from fifth position, so current was head. And then, till when we were doing it? We were doing it till our current becomes null. So while current is not equal to null. Till that we have to reverse the list. So what we were doing first? Firstly, we were node star, we were creating the next. Next was currents next. Very simple. Then what we were doing? We were pointing the currents next to previous, right? And then previous was updated to its next position, which was current. And then we're updating current to its next position, which was next. And then you will close it, and then after this will be completed, our reversed head will be at previous. So we'll just return previous, right? Then we'll close it off. Simple pseudocode we have. Such 1, 2, 3, 4, 5 lines of code reverses. And for the edge cases, right? It is very simple, similar to the previous question we solved. Edge cases if head is null, similar, right? Or heads next is null. If there is a empty, right, empty list, then we can't reverse it. And if there is only one element in the list, then also there is no need to reverse it. So we will just return the head. Then we will execute our while loop. This is our pseudo code. Let's quickly code this up. This is a easy problem, I would say rather. And we had our edge cases. Head is equal to null, or heads next is equal to null. Then we will return head, right? And then we have our while loop. Before while loop we had some variables, right? List node star current is equal to head, and previous star previous is equal to null, right? And then return previous, right? Previous will store our current head, and we have to run this loop till our head is not null. What we were doing, we were having a temporary node here, which was next. Next used to have our currents next. Then we will update our current next to currents next to previous, right? It will point to previous, and then previous will be current, and current will be next, and we have to iterate it over till our current become null. So this is your solution. Let's go run this and see the test cases. Are all three sample test cases have passed? 1, 3, 4, 5, 1, 2, and the empty one edge case. Then let's just submit this code. So see, we have achieved the 100% is the solution 100%. So we have not seen the time complexity here. Let's just quickly see the time complexity of the solution. So here we see that list current becomes null, and we are iterating over the list till the end, right? So I would say the time complexity here is big of n, right? Because we are iterating till the end of the list. So the time complexity is big of n, right? And what is the space complexity of the solution? We are not using any extra auxiliary stack space or anything like that. The space is also constant. That the node we are creating, we are just using it, and the ideal case will be to use this node and also delete this pointer as well, to free up the memory. So delete this node as well. These are better approaches. So to free up the memory which you are using. So I would say we actually almost created this node, but we are freeing it up, right? So this is in the dynamic memory. We are not using it in a heap. We are using it in a heap, not in the stack, right? So the space velocity we can say we are using constant space because we or I can create a temporary variable here one, then like just use that instead of creating it again and again here. So it is similar. There is no big deal in that. So that's it for this one, guys. I hope you like this one. Please feel free to reach to me out in the comment section below which topics I should cover next. Thank you.